All right, welcome. This video is going to be a training video for basically an introduction to MasterCAM. I will not be covering any sort of tool pathing or theory on CAM. We will just be talking about the setup for MasterCAM, the 5 different steps you have to go through anytime you set up something on MasterCAM. So with that, oh, and then background for this video, you don't have to have any further experience with CAM, although learning Fusion CAM first would probably be helpful. Regardless, this will be a good introduction. Okay, let's jump over to MasterCAM. So I've just opened up an instance of MasterCAM, and right off the bat, there are 5 things you have to do. Those 5 things in an order that is helpful but not absolutely necessary is telling it what machine you're going to be using, bringing in some sort of geometry, whether that's a 3D model or just wireframe geometry, setting up your datums or your planes, as MasterCAM refers to them as, setting up your stock definition, which is the shape and dimensions of your original stock that you'll be machining, and then your tool library, telling it what tools you'll be using. So let's start with the first one, machine definition. Well, not the machine definition, but what machine I'll be using is along this tab under machine, mill. We're going to be using the, say, Haas DM1, which is our 3-axis Haas mill. So I click on that and it'll bring in a machine group right here. This machine group, you can bring in more machine groups if you're going to be doing lots of different parts in this same MasterCAM file, but you really only need one typically. Next thing, I need to bring in geometry. That is done through File. If you hit Open, it will clear everything you've done and only open your part. So I try to make it a habit to use Merge. You can bring in multiple parts if you use Merge. You can only bring in one if you use Open. But if this is the first thing you do instead of your machine selection, you can just use Open. So I'm going to go with Merge right now. We're going to go here, drop down all files, and we'll be using a CAM practice piece. So I have this random part that's just meant for learning CAM. I'm going to hit green check over here. And awesome, we have our geometry. So those are the first 2 things. It doesn't matter the order in which you do those 2 things, but they do need to precede the 3rd step. So the 3rd step is going to be your datum. MasterCAM refers to them as your planes. This is down here in the bottom corner, planes. There are 2 different main ways to set up a plane or datum in MasterCAM. I'm going to show you both, and they both have advantages. This part is going to need 2 setups because I can do these operations from the top, but this hole and this slot need to be done from another setup. So what I'll do is I'll set up this top setup using an existing work coordinate system called top. You can see over here, and if we look at the bottom of the part, we have Z, X, and Y. That's the orientation. If I click through these different datums, you can see that they're oriented differently. We'll be using top. So in order to get this part down to that datum in a way that makes sense for probing, we're going to come to transform along the top ribbon. I'm going to use dynamic transform. Dynamic is kind of just all of these, translates and rotates, move to origin, pushed into one. So we click on that, asks us to select what we want to move, so we end selection, and then I can place this, what I'm going to refer to as handles, down on the part. It's important to note that this thing I'm moving around, the handles, are not your datum. I can put it wherever, and it just allows me to manipulate the part on those 3 axes. Once I hit done for this dynamic transform, it goes away forever and doesn't exist. What I care about is this datum in blue right there that we see. So I'm going to click right here and show you a few different things. I can click on the shaft of the arrow to move it up and down, and I can type in a value, but I definitely don't want to move it 1,000 inches. I can click on a plane, and that moves it in that plane only. So if I rotate, you can see. It's a really hard one to see. It's only moving in that plane. It's not going up or down. You can click on the handles of these arcs. Now, like that, and then type in a degree, or like this and type in a degree. Or you can click on the ball at the origin of the handles. That allows you to move the whole part in free space. Another really important thing to note when you're using the transform tool, and it's extremely handy in applications outside of just moving your part, there's this hidden button that fades out when you're not right next to it. It looks like a couple of shapes right now. What that means is when I do anything on this datum, when I manipulate the handles, it will move the part. Now if I click it once, it changes it to a vector. Now whenever I move the handles, they will move the handles relative to the part, like this. Helpful if you want to reposition your part. Say I wanted to put it on this imaginary corner. I can't click on the datum of the handles or the origin of the handles and put it there accurately. But what I can do is come down and put it on this corner. Then I can click on the Z, move it up, and I can snap it to a height of something else, say the height of this cylinder. You can see the dotted lines that go over to it. If I click on that, now it is where that imaginary corner would be. Then I can come, punch this again, and now when I move the part, it's moving the part relative to the global coordinate system. I'm going to go ahead and put it down right here and hit green check. I'm also going to clear the colors because I like gray. Awesome. So you can see that it's lined up just perfect on that corner. And if I double check by clicking on the top datum, it's oriented the way that I want. For our Haas machines, if you open the door, you're standing in the machine, you open the door and look into the machine, you are looking along the positive y-axis. And running in front of you, off to the right, is positive x. So if I orient this, oh, and then positive z is obviously up. If I orient this like so, this is as if I opened the door and was looking into the machine. So it would be in the vice jaws with one vice jaw on this face and one vice jaw on this back face. And that would match the coordinate system I've defined right here. It's really important that you match the coordinate system in the machine to the datum that you set up here. So this is one way to set up a datum. You can move the part using dynamic transform to an existing datum. And there's always these datums when you open up an instance of MasterCAM. Now, it's a little bit of work to do that. Sometimes you have to get creative, you have to move the handles around on the part before you can move it to where you want. But it's really important to be able to use that transform tool, because later when you start getting into more complicated camming, it's actually helpful for moving wireframes around and different things. So a good tool to understand, but not the easiest way to set up your datum. So that's one setup. I mentioned we need another setup over here. I'll show you the other way to make another setup. You could just do this off the bat, but you will for sure have to do this if you have more than one setup. Down here is a little shortcut that if you click on this datum, it automatically allows you to make a new work coordinate system. It's the same as if you come up here and clicked on the green plus where it says create a new plane. So I'm just going to click on that. Now I have these handles again. Really important distinction though is these are no longer handles. This is actually my work coordinate system. So when I put this down, that is where my work coordinate system will be relative to my part. So I'm going to come over here and throw it on this corner. Now, I don't like the orientation because I need Z to be coming perpendicular to this surface. So I'm going to rotate it -90 degrees. I'm also going to move it so that it's in line with this edge. Now it's an imaginary corner, but just wanted to show you how to snap to things that don't exist. Alternatively, I could click on it and come snap over here as my datum. So we hit check, and now you'll see that it says plane this. I forgot to show you. Let's do that one more time. Delete, start, click, rotate -90. Okay, over here in this sidebar, before I hit enter or green check, you can name it. So maybe I name this setup 2. And then we can hit check. Now it's whatever you want it named. You can also just edit it or rename it. Editing allows you to move that around if you didn't put it where you wanted to or it's the wrong orientation. Okay, so there's the 2 different ways to set up your datum. That's the 3rd thing you need to do when you open up MasterCAM and you start any sort of new cam. I want to throw out a couple plugs here though with your datum before we keep going. You need to place your datums in a location on your part that you can actually probe. Sounds like a stupid comment, but you have to think about, how am I going to probe this part? For example, if I put the datum on the top of this cylinder, you can probe a cylinder with the preset programs on the Haas probe or the Renishaw probe, but I haven't cut this part yet, so that cylinder doesn't actually exist. It's just buried in the part. So I can't accurately probe it. I could probe any corner of the stock. I could probe the center of the stock, the top surface, the side surface. Those are all feasible. But, oh, here's another good example. If I was setting up this datum and I had already cut everything on top, now it looks like my model, my stock looks like my model except for this slot. I can't physically probe this non-existent corner because I've cut it away, which is actually why I moved the datum over to here. So these are just some things you need to think about. One other thing you want to think about is that you want to try to reduce error. Every time you make a new setup, you introduce some error into your part. So to illustrate this, I'll just use a couple examples. If I have this corner over here as my datum, I cut everything, and then I come up here and use this back corner as my datum. Those 2 datums, this corner and this corner, do not share any plane. So if my stock is at all the wrong size, which is always the case in a not perfect world, at some level it's not going to be the exact size you define it as. This datum will be shifted back relative to this one, whatever stock size error you have. What that amounts to is, if this setup interacts with this setup at all, they will be shifted relative to each other. Let me draw a quick picture. We'll come back to the camera. Let's draw a quick little cube. All right. Okay. So with this cube, you'd have to drill these 2 holes on different setups. And they're supposed to, for this model, intersect perfectly. Now I'm going to draw this again, and I'm going to exaggerate what happens when you introduce stock error. Say that that's supposed to be a 1 inch by 1 inch by 1 inch cube, but you totally botched it, and it's a 6 inch by 1 inch by 1 inch rectangle. Okay, so if you use the datums that I have selected with these circles to cut your bores, oh, I should draw it on this one as well. Those holes will not interfere at all. Now, obviously, when you make parts, your error is much more like on the order of thousandths of an inch, not inches. But you can see that if I drilled through here and then drilled down here, they don't intersect at all where you want them to in this setting. There are a lot of different ways that this error can manifest, but the short of the long is you want to try to get your datums to share as many planes as possible. So coming back to MasterCAM, The datums we currently have selected are okay, but not great. They do share this top plane. So we know that I can probe this surface for this datum, and then I can probe this surface again for setup 2, which is right here. You want to be able to probe the same physical location on your part for each datum as often as possible. So probably there's lots of good options, but one of the good options would be to use this corner and this corner for the 2 setups. That means they share this face and this face. The only face that's different is this one and this one. And you've reduced your stock error to 1 dimension as opposed to all 3. Let's see, anything else with datums? You'll want to place your datum in a place that allows you to hold the stock in the most rigid way possible. I will just say that and not go into all the different possibilities, but you will want to think about your workpiece rigidity when you're placing your datum. Okay, so that's a quick overview for datums. We have the top setup, which will be our first setup, and then we have setup 2, which is our second setup, just to cut this slot and hole. Again, it goes set up what machine you'll be using. Right here, under the machine ribbon. Then you want to bring in geometry, in our case a 3D model, sometimes just wireframe geometry. And then your datums. That can be done 2 different ways. The easy way doesn't teach you how to use the transform tool, but it is much easier. So get familiar with the transform tool, but know that there are 2 different ways to set your datum. Okay, the fourth thing is your stock setup. Again, like datums, there are different ways to do this, and they have different advantages. Stock setup is found, oh, I should refresh where we are in the ribbon. When you come and open an instance of MasterCAM, you'll need to go to machine, and that will let you define your machine. Once you do that, it'll make a new ribbon option, which is toolpaths. Everything else we're doing is in toolpaths. So in toolpaths, we've got this sidebar. Hit the drop down on properties. If you need to, hit the drop down on machine group. And then you can click on stock setup. There are a couple other things here that you need to do as well. But if you click on any of these, files, tool settings, or stock setup, it'll bring up the same dialog box just with a ribbon across the top to toggle through those options. I'm actually going to start with files. These files should be preset and you should never need to change them. They're things like where is the machine definition found, what tool library should be default, where is the post file found. You shouldn't need to change that. Tool settings, there are some things you need to change. You don't have to, but it is probably in your best interest to change your feed calculation to from material. Most of your feeds and speeds you will do by hand or from experience, but MasterCAM's default for from material in aluminum 6061 is correct for drills. So if you do what I'm about to show you, you don't have to set your feeds and speeds for drilling in aluminum. Now, you do have to still do it for steel. So this is only helpful for aluminum. I'm going to come in and down here hit select. I'm going to delete the 2024, hit get from library, and then say 6061. Check. It's selected. I can hit green check, and it will update what my material is. If I have from material and the correct material selected, it will automatically do those feed and speed calculations for drilling specifically. In the toolpath configuration, I'm going to check these 2 boxes. We do not want to assign toolpath numbers sequentially because we have preset tools in the DM1 and VF4. But we do want to warn the programmer if there are duplicate tool numbers because you can't physically accomplish that in one program. And then we do want to use the tool step PEC coolant settings. This is primarily, again, useful for drilling, but a handy thing when you do need it. We'll also leave this one off. Search tool library when entering a tool. You can turn it on if you want, but I just haven't found it super useful. Those are the only things I'm going to change in this menu. Go ahead and explore them to see what they do. There are instances where other settings can be useful, but 9 times out of 10, this setup will work great. Then we move to the stock setup. Okay, so there's a few different ways to do this. I'll show you the easiest way first, and then show you a couple other tools. The easiest way is going to be to click on bounding box. Once you do that, you select your geometry. So I'm going to be cutting out this part. You hit end selection, and it will automatically size stock to all of the largest features that your part has. In our case, this would work great. Sometimes, though, you will be working with round parts. So you want to say that actually I have a cylinder, and it's centered around the z-axis, but I don't want it centered on my datum. So you hit uncheck center on axis over here, and it will center it around your part. So this would also be an option. Not a great option, but it would definitely be an option. Now say that I know I don't have a radius of 3.6. I actually have a, let's say a 7-inch round. So, well, no, a little bigger, 7.5-inch round. That would be this radius. You can update it. Another way to do that is to click on the surface of this part. Say I want to surface the top off. I would grab it and pull it up, maybe 100 thou. So now I have a little extra stock to work with, and I can face it down before I cut my part. Let's go back to a rectangle though. I'm going to go ahead and add a little bit of stock here. Let's say 25 thou that I want to work with, but let's say the other dimensions are correct. So I'm just going to leave it. Another thing to note before we hit check is creating geometry. I have made a box that's a little bit bigger than what our actual part is, and I won't be able to select the geometry of my stock unless I add some geometry here. The only one that I've found useful ever is lines and arcs, because these other options are largely redundant, but you can look into them as well if you'd like. Lines and arcs just draws lines on all the edges of your stock. We'll see that once I hit check. Corner points puts points in those corners, redundant because you have the lines. Center points puts points in the center of your lines, also redundant because you can select the center of a line. Face center points will put points on the center of the faces. That is not redundant, but usually not useful. And then solid, we don't need to make a solid out of this. Okay, I'm going to hit lines and arcs, check, and I'm going to close this window for a moment. You'll see that it put down some wireframe blue lines that I can select. They're highlighting here. Useful if I need to select regions that aren't a part of my 3D model. For example, this corner over here. All right, so I'm going to jump back in here and show you a couple other tools before we move on. The bounding box is a nice way to create the settings you want, hit check, and it'll do the work for you. What it did though is it populated these 6 yellow boxes for you. It put some values in your X, Y, and Z dimensions of your stock, and then it populated the coordinates. These coordinates are how far you want to shift this point over from your world coordinate system, or whatever stock plane you have selected right here. We're using top, so it's this datum. So what this means is that point, which is on the top center of this rectangular face, well, the top of the block, the center of that face, is shifted over -3 inches in X and +2 inches in Y, and then up 25 thou in Z. Now, I have display checked, which is useful, and wireframe. It'll show me just the red dotted edges. Problem is, I also have blue lines covering those up. So just to show you, if I change it to a solid instead of wireframe, that stock definition is there. Your stock definition is not always critical, but it's needed if you ever want to render and verify your part visually in MasterCAM before you post, which you should always be doing. And then it's also helpful for a couple other settings in toolpaths, such as, it's actually called stock, but it looks back to the stock to see what needs cutting still. I won't go into that any further now, but it's really important that you know how to do this, and most of the time you need to. There are a couple instances where you won't actually need to set up a stock definition to accomplish your toolpath. Okay, so we've talked about how to do it manually with these 6 yellow boxes. We've talked about the viewing options here and bounding box. You can look into these other options as you need. I should mention these options up at the top of the dialog box. Stock plane is the plane that you are working off for your stock definition. And then shape, you can change it to cylinder, rectangle. You can also create a CAD file if you have a funny shape for your stock, and then load that in here. But that will cover the basics of how to set up your stock. So we've done the first 4 things. Truth be told, you can start camming at this point, but it is very helpful to do the 5th item, which is set up your tools before you start camming and creating toolpaths. Reason being, if you open up Tool Manager, which is where you set up your tool library, and mentally go through what tools you think you need, you will run into problems with your setup earlier than later. If I run into a problem with my setup 4 hours into a cam, I have to scrap the whole thing and start over. Where if I do it mentally now, I've only worked on the part for maybe 5 or 10 minutes, and starting over is not nearly as painful. So while it's not critical, you can introduce tools as you create toolpaths and as you need them. It is still very helpful to try to do as much as you can up front. For example, I will just bring in a couple tools and walk you through verbally what I do mentally when I create my tools in the tool library. So I'll look at my part and I say, okay, I see the features that I have to cut. What types of toolpaths am I going to use, and what types of tools am I going to use for those? And I'll step through each feature in my mind and say, okay, I need a 1/2 inch bull nose. I need a spot drill. I need a 1/2 inch drill. I need maybe a square nose 3/8. I need a tool with long enough reach to do this and this. This is my deepest pocket. And I'll step through all of those things. As I do that, I will run into possibly some problems, or, well, this part's not too complicated. You probably won't run into any problems. But you will start to discover things about your part and your datum and your order of operations as you mentally step through it. So to spare you all those details, I'll just bring in a couple of tools. Right now everything's blank. I have the, okay, this would be the tool library here. This one is the project library. Now the project library is the only thing you have visibility to when you're creating a toolpath. You don't have visibility to this. So you need Toolpath Manager to move items from different libraries into your project library. So if I hit open here, I can pick which library I want to be pulling from. Let's say the DM1 library. I'm going to order them by tool number. I know I need a spot drill to drill those holes, so I'm going to double click on it and it'll move it into my project library. I want to use the 3 flute bull nose 1/2 inch end mill. I can also click on the up to push it up. And then I want to get a, let's just say that's a 1/2 inch drill hole. I don't see a drill in here because we don't have drills preset for the DM1 library. So I need to come and open this and open the mill inch library. Now I can alternatively create a tool and just create a drill right here next, and fill out all of the information that I need. But if I do that, I'll be missing some of the information like default pec and step, retract heights, different things like that. So it is useful to pull it from an existing library. Okay, this library has only like 500 tools in it. I don't want to go searching. So I'm going to turn on my filter, and then I'm going to specify what items I want in my filter. I don't care what size, but I do not want an end mill. I want a drill. So drill is highlighted. I'm going to hit check. Now there's only maybe like 200 tools I have to go through. I'm going to sort them by diameter and then scroll down to 1/2 inch. Double click on that and it moves it up. Now note 5 and 6, numbers 5 and 6 are correct for my spot drill and my bullnose end mill. But I don't have a pocket for tool 162 on the DM1. We only have 18 workable tools with a 19 tool probe. So I'm going to double click on this one and edit some things in the tool definition. All of this is fine. But if I hit next, I want to change the tool number to be tool 4, which I know has a drill chuck in that pocket. Notice that when I change the tool number, it changed the length offset and the diameter offset. You always want those matching. I do not know why it's even an option to have them different. You're going to get some real issues with your program if you ever change this. So make sure they're all matching. I can hit calculator and it will automatically calculate the feeds and speeds for this drill. I could change maybe the name, or if it was a carbide, I could change it to a carbide. But this is all fine. So I hit calculator to recalculate the feeds and speeds, well, the feed rates. And then over here, I updated the tool number, so I'm going to hit finish, and now that's correct. I can edit these other ones as well if I ever need to. Say I want to recalculate the feed rate for this spot drill, finish, it's good to go. Now if I hit check and go to make an operation, say just a drill cycle, oh, that is no good. We just crashed MasterCAM. Well, before I hit OK, I'm going to finish where we were. If I open up a toolpath, it will allow me to select from those 3 tools that I just made. Wow, we are so lucky that that crash occurred now and not in the middle of everything. Well, tools was the last thing we needed to do. So we went into Tool Manager up on this ribbon. We moved tools from an existing library. We could create a new tool into our project library. And that project library is what you can see when you create toolpaths. Again, like I mentioned earlier, if you are in the middle of a toolpath and you're like, you know what, I should really use a different tool for this, you can go into your tool manager and add it, or you can just create a new tool directly in your toolpath parameters. So it's not the end of the day if you don't get every single tool into your tool manager up front, but it is helpful to help you mentally step through what you want to do with your part before you start doing it. As odd as it might seem, you need to understand how to create your entire part before you start camming it. What you don't want to do is start blindly stabbing in the dark and then work into a spot where now it's not possible to make your part. Order of operations is going to be very critical typically. What tools you use is important, and where you put your datums is also very important. So there is the introduction to MasterCAM setup, its basics. As a recap, set up your machine, tell the program what machine it will be posting to, bring in your geometry, be that 3D model or wireframe, set up your datums or your planes, define your stock, and then go through and set up the tools that you know you will need. The order on those 5 items is not exact. You do have to set up machine and geometry before you set up your datum and stock. You can do tools at any point after machine, and datum and stock can be interchanged, though it's usually a good idea to do your datum first. Let's see, let's go ahead and stop sharing this and move back. Okay, so there are the basics for the 5 things you need to do when you set up CAM. If you have questions, please sit down after you've viewed this training and go through it with an LA over your shoulder and try it out for yourself. Thanks.